Today we're going to practice solving systems by elimination. At this point, you should know what a systems of equations is. And you should also know how to solve it either by graphing or by substitution. So this is just another method. We use this method when graphing isn't feasible and substitution just doesn't work very well. So I look at this system of equations. I have 2x minus 4y equals 20 and 5x plus 4y equals negative 6. If you notice, the two equations, neither one of them says x equals or y equals. If they did, that would make it very easy. So I could solve one of these for x or one of these for y, but if I can have a faster method, I would. And sometimes this is also called linear combination, because what you're actually doing is you're combining them. So when I look at these two, I'm going to combine them as if I were adding them. So I'm going to combine or add my x's. So I take 2x and 5x and I get 7x. And I take negative 4y and 4y. And if you notice, what happens is those actually cancel out. So that gives me 0. And then I'm left with 20 minus 6 is 14. Now, this is my new equation. And how great is that? Because it's a one-step equation. And now I know that if I divide both sides by 7, I get x equals 2. Well, if I know that x equals 2, all I have to do is plug it into one of my equations. So I'm going to just pick the first one. And I'm going to plug that in, and I'm going to get 2 instead of times x. I'm going to substitute 2 in for x. Minus 4y equals 20. Now I'm just going to solve. I have 4 minus 4y equals 20. Subtract 4 from both sides. My negative 4y drops down. 20 minus 4 is positive, 16. And I divide both sides by negative 4. And I get y equals negative 4. So my solution to this problem is x equals 2 and y is negative 4. Now, looking at this problem, I don't have x equals anything. I don't know. And I don't have y equals anything. So substitution is not a good method. But if I look and I want to combine these, I get 3x plus 3x is 6x. 5y minus 6y is negative 1y. And I notice that nothing canceled out. So that's not going to work either. So now I'm going to have to force it to work. And this is where elimination becomes just a little bit, not confusing, but takes a little bit more thought. So I look at my coefficients. So I have positive 3 and positive 3, and positive 5 and negative 6. Now, if you remember back to the first problem, we had negative 4 and positive 4. That was great because my negative 4 and my positive 4 both canceled. But in here, I don't have a positive and a negative of the same value. So I'm going to make it be that. So if I look, I see that I have a positive 3 and a negative 3, or a positive 3 and a positive 3. If one of those were negative, this would be beautiful and it would cancel out. So what I'm going to do is I'm going to make it negative. And if you remember back to solving equations, we learned that you can multiply or divide an equation by anything you want as long as you do it to every term. So in this case, I'm going to take this equation here and I'm going to multiply everything by negative 1. Now I'm going to rewrite my equations. So the new equation now, the first one stays the same. And I get 3x plus 5y equals 7.6. Notice I didn't do anything. And the next one, I'm going to multiply negative 3x by negative 1, and I get minus 3x. and I multiply negative 6y by negative 1, and I get positive 6y. And I multiply negative 7.8 by negative 1, and I get positive 7.8. Now, when I combine them, negative 3 and positive 3 cancel. Always check to make sure. And then I'm left with 11y. And 7.6 and 7.8, 6 plus 8 is 14, carry the 1, and you get 15.4. Then divide both sides by 11. Those cancel, and I get 1.4 equals y. Then you're going to take 1.4, plug it back in for y in one of your equations, and I always just do it to the first one. So I have 3x plus 5 times 1.4 equals 7.6. I'm going to solve that. I get 3x plus 7 equals 7.6. Subtract 7 from both sides. The 3x drops down. My 7's cancel. I get 0.6. Divide both sides by 3, and I get x equals 0.2. So my final answer is 0.2, 1.4. And that would be the point of intersection, which would be awful if you were trying to graph it and trying to find the exact answer. Okay, now, we've done an example where the variables cancel out evenly because they have their opposites. We did an example where the coefficients were the same number, but we had to make one of them opposite. Now we're going to do an example that is most common, and that's when the coefficients are neither the same number nor the opposites. So, looking at this, we can look at our values, and we can combine. Negative 12 and negative 4 would give me 8, and 3 and 2 would give me 5. So neither one of those is going to work. And you can do this in your head. I don't expect you to rewrite it. So I look, I have 12 and negative 4, and I have 3 and 2. Neither one of them are the same coefficient. So this is going to take a little bit more work than multiplying just by negative 1. So I look to see, are they multiples of each other? Well, if I look, 12 and 4 are multiples because 3 times 4 will give me 12. 3 and 2, I can multiply them together and get 6, but that's twice as much work. So I'm going to start with the x's. That's what I'm going to work with. And I'm going to try to make them the same. So if I look here, I see one's already positive and one's negative, so I don't have to worry about that. But I would really like them to be the same number. Well, I can multiply negative 4 by 3, and that will give me negative 12. And if you remember, if you multiply one side, one term of the equation, you have to multiply them all. So all I'm going to do is rewrite my equation. And please take the time to rewrite the equation. I know it takes a little bit more work, but it will keep you from making a mistake. Neatness matters at this point. So now I'm going to multiply every term by 3. So remember, distributing that 3 to every single term. So negative 4 times 3 is negative 12x, and 3 times 2y is 6y, and 3 times 12 is 36. Now, combine them. 12 and negative 12 cancel. 3y and 6y is 9y. And 18 and 36 is 54, sorry. Then divide both sides by 9, and you get y equals 6. And then, as always, we just plug it in. So I'm going to take it and plug it into the original, first one. And I'm going to have 12x plus 3 times 6 equals 18. 12x plus 18 equals 18. Subtract 18 from both sides. You get 12x equals 0. Therefore, x equals 0. Therefore, my final answer is 0, 6. And that is the point of intersection or where these two lines cross. Now let's look at this one. I would like you to try it first in your notes, pause the video, and then after you finish it, play the video and see if you get the right answer. So looking at these, I have positive 5 and positive 7, and negative 3 and negative 3. I'm going to change the negative 3 and negative 3 to a positive and a negative. And again, it doesn't matter which one you change it to. So I'm going to multiply the first one this time by negative 1. So I have negative 5x plus 3y equals negative 4. And then I'm just rewriting the second equation, making sure that you're rewriting and taking your time to be neat. Negative 5 plus 7 is positive 2x. My 3's cancel, always check, equals negative 20. Let's divide both sides by 2. I get x equals negative 10. Take negative 10, plug it into the original equation. Whoops, sorry, plug it into x. 5 times negative 10 minus 3y equals 4. Negative 50 minus 3y equals 4. Add 50 to both sides. You get negative 3y equals 54. Divide both sides by 3, and you get y equals negative 18. So my final answer is negative 10, negative 18. Again, I would like you to copy this problem down, try it, and then play the video. So I look, I have 5 and 2, negative 6 and 2. Neither one of those are the same. They're not opposites of each other, so I have to force it. Now, 5 and 2 are not multiples of each other, but 6 and 2, I can multiply 2 by 3 to get 6. So I'm going to change the y this time. So I'm going to multiply everything by 3. That will give me a negative 6 and a positive 6. So again, I'm rewriting 5x minus 6y equals 1. I just rewrote it. And then I'm multiplying every term in here by 3. So I get 6x plus 6y equals 54. Combine like terms, 5x and 6x give me 11x. Negative 6y and positive 6y cancel, and 54 plus 1 is 55. Divide both sides by 11, and you get x equals 5. Take x, plug it into one of the original equations. I get 5 times 5 minus 6y equals 1. 25 minus 6y equals 1. Subtract 24 from, sorry, my brain went ahead of myself there. Subtract 25 from both sides. Those cancel, and I get negative 6y equals negative 24. Y equals 4. So then my final answer is 5, 4.